Dominic Parker, and today we're going to show you the physics of soccer. I'm going to show you the forces acting on a soccer ball during flight, which are lift, the Magnus effect, and drag. Alright, so first, here's the soccer ball, and as it is flying through the air, air currents, these are the air currents, will go around. Like that. But in real life, the air does not flow perfectly around it in a nice smooth path because of the stitching of the soccer ball. It will cause more turbulent air, and in real life, this is will look more like this. So it'll go, and then once it hits the stitching, it will more or less the air gets disturbed by the stitching and other effects of the real world. So what causes the ball to lift is as the air flows on top, the air below is flowing a lot faster than the air over the top, causing lower pressure below, causing the ball to rise. Lower pressure above, causing the air pressure to push more up, causing the ball to rise. And then the formula for lift would be L equals 4/3 4 pi squared rho, which is the density of the air, b cubed, which is the radius of the ball, and then s, which is the spin. That's how you'd find the theoretical lift of the ball without any of the turbulent air caused by the stitching and not perfectly roundness of the soccer ball. So in 1997, a Brazilian player named Roberto Carlos scored a goal he did not know he was using physics, but all the ideas behind it are. So Roberto Carlos was about 35 yards away from the goal, which is quite a distance. So here's the ball, and here's Roberto Carlos. And then there's a wall of defenders right here. He ended up kicking the ball with the outside of his foot, going around the wall, and then curving it into the goal and scoring. Many thought it was a fluke, or some even think the video is fake, but it truly happened, and not knowing the physics behind it, but he hit it with the outside of his foot and curved it in what is known as the Magnus effect, which is the spin on the ball causing it to curve. Now I'll show you the video of Roberto Carlos scoring this amazing free kick. So as you see in this video, he curves it around, and scientists have shown that had gravity and drag not been affecting this ball, it would have actually followed a path and then still kept curving until it just got into an infinitely small spiral where it'd just be spinning like that. So if that shows you how much curve and effect that this Magnus effect has on the ball, it would have gone past the goal and then came back out. So now I'll show you what the Magnus effect actually is. So here's the ball. Think of this as a top view of the ball. So the ball, say, is spinning, well, in Roberto Carlos's case, is spinning in this direction. And moving this way. So it's spinning, and air is still flowing past it, like in the past diagram. So as it's going, the air wants to follow the path of, I guess you'd say, least resistance. So as the ball is spinning this way, the air wants to flow in the direction that it's spinning. So the air over here on the left side of the ball would be moving much faster than the air moving on this side of the ball, and faster moving air is less dense. So as air is flowing, the air is less dense, causing a lot greater force pushing this way, causing the ball to change its flight pattern and curve. So this is known as the Magnus effect. So as the ball is curving, the only force is not just this Magnus force. It's also drag, which is opposing the direction from, it's the air being pushed out of the way. So the drag is in this direction. So the drag is pushing away from the ball, which is also causing it to slow down and eventually hit the ground. Soccer is not just kicking the ball, it is the outside forces and physics behind it that make it happen. And not even in just soccer, but sports, and not even sports, the entire world. Physics makes the world go round, and this is the physics of soccer. Thank you for watching.